to the last lesson on our systems unit. So it's really only 4 lessons. This isn't like you've been exposed to word problems in the substitution portion. This is just connecting now word problems with being able to solve it anyway. Again, the trickier part is setting up the word problems. Once we know the elimination strategy, word problems are much easier to set up actually. Much, much, much easier to set up. So here's, again, what we need to do when we set up a word problem. You have to define your variables. Have to. That means you need to say, let x equal blank and let y equal blank. Maybe you don't have to say let. That's more formal math. That's what we do when we start proving stuff. You'll do that a lot in 10th grade. You'll do a lot of that. Then you make 2 equations. That's the hard part. Kids are like, I don't even know how to make an equation. Well, you're going to have to make 2 of them. You do the best you can. You look for words, words like is the biggie. Like, if you see the word is, that means equals. That means they just told you an equation. Okay? Yeah, that's about it. And then you solve. Now you can solve through a bunch of different strategies. You can use linear, let's say elimination, or you could also use substitution. So you're going to have to, that's that level 4 step. That's being able to identify which one is the most effective method for you to use. Okay, so let's do it. Again, define variables, make 2 equations, and then solve. And you can solve 2 different ways. You can solve 3, but I don't know anybody that's going to graph. I mean, there's a third strategy to graph, but typically kids aren't going to do that. So eliminate, substitute, you choose. So the larger of 2 numbers is 11 more than twice the smaller. The sum of the numbers is less than 7 times the smaller. We already did this one, I feel like. I remember this one. Let's just do it again. Let's do it again. So the larger of 2 numbers, I like to say x is small, y is large, is big. X small first. But you could do big and then small if you want. But I'm still doing step 1 where I am defining my variables. Step 2 is the hard part. Now I need the equations. So I am not shutting down, I'm just looking for keywords. I see the word is, which means my equation is right around there. So the larger, that's y, of 2 numbers is equals 11 more than twice the smaller. So 2 times the smaller and 11 more. I already know I'm going to use substitution. You want to know why I know that? Because I have y all by its lonesome. So that's, again, level 4, being able to see, okay, I have a variable by itself. I can quickly substitute that in. Now I have the sum of the numbers is. Again, you can look for the word is, and that means, hey, there's an equation right in here somewhere. The sum of the numbers, that means add them up. X plus y is equals 1 less than, remember when you have less than, you're less important, than 7 times the smaller. Small is x. I'm going to write my rationale here, so I'm going to substitute because y is alone. That's why I'm substituting. You need to identify, hey, you have a variable by itself, you can go ahead and substitute. So I'm going to do that. X plus y, but y is a substitute, so I have parenthesis 2x plus 11 equals 7x minus 1. This parenthesis can kind of a lot mess kids up. Because they look at it and they're like, so what am I supposed to do? with it? Am I supposed to distribute? But you don't, because there's nothing face planted to it. You only distribute if it looked like this. That's when you distribute. There's something sticking, like, hey, I want to get inside there. But here, nothing cares about getting inside. Okay? So, then you can just combine like terms. 3x plus 11 equals 7x. Multitasking plus a negative 1. Move my x. I like to move my smallest x. And I get, I don't know how you guys like to do your algebra, I get 11 equals 4x plus a negative 1 plus 1 plus 1. 12 is 4x. X equals 3. Oh, but we are solving a system of equations, so we need our y. So this little 3 needs to go back up here. Back where you put parentheses. Y equals 2 times 3 plus 11. 6 plus 11, 17. So the system of this equation is 3 and 17. But what does that mean? This is real life application. I was talking about the two numbers. So my small number is 3. And my large number is 17. Okay, so again, today you're mixing it up, where we are going to either solve with substitution or elimination, and you need to be able to identify which one is most effective to use. Okay, I love this kind. This kind is definitely, this is what our main goal today is, this kind. The other kind was more of the 6.2 goal, the substitution goal, but being able to use it with elimination is this type of problem. So the cost of admission to the Spring Carnival is $39 for a group of 8 kids and 3 adults. The admission is $43 for another group of 11 kids and 2 adults. What was the initial admission price for the kid and adult? So what I'm going to do, define my variable. Let x equal kid, y is adult. That's always the first step. Always the first step is to define your variable. Okay, so now I have 2 situations. Again, my goal is 2 equations, right? So I have the cost of admission is $39 for a group of 8 kids, 3 adults. So 8 kids plus 3 adults is $39, right? $8 per kid, 8x, plus $3 per adult, or 3 adults times $5, I kind of flipped that accidentally, is $39. Now here's my other situation. The admission was $43 for another group of 11 kids plus 2 adults is $43. How much are they? Now, I am not going to use substitution because I have no variable all by its lonesome. So I'm going to use elimination because the variables are lined up. And now I know how to do that. So my goal with elimination is to cancel out. So I'm going to choose to cancel, since I don't see anything that can cancel out right away, I'm just going to choose to cancel out my x. So I want to turn my 8 and 11 into opposites. So what's the common denominator with 8 and 11? Don't know, I choose 88 then. Yeah, so I want to turn them both into 88s. A positive 88 and a negative 88. So I'll go ahead and do my negative first. I'm going to times 8 by negative 11. That'll give me my negative 88. And I'm going to times this second equation by a positive 8. And now I distribute. And yep, you're definitely going to need to be able to use your calc today. So that is negative, I feel like I need room. Negative 88x plus a negative 33y equals 39 times negative 11 is negative 429. Okay? Be careful for your integers. Be so careful. Now my second equation after I distribute to everything, 8 times 11 is positive 88x, plus 8 times 2 is 16y, equals 8 times 43 is 344. That's 344. Ethan?
Why couldn't we just did the y's?
You could.
It says smaller.
Yep, so that's level 4 too. So what Ethan said is, oh my gosh, these numbers are huge. Why couldn't I just canceled out my y because they're smaller numbers? You sure could. You absolutely could, but some kids get confused by that. That's good thinking though. I personally would do that, but what's nice, some kids just like to cancel out that first variable. Okay, so now again, my purpose for that was to cancel out. My goal is achieved. Now my x is eliminated. Then I have negative 33 plus 16, which is negative 17y, equals 429, wait, that's negative 429, plus 344 is negative 85. And then I divide that by a negative 17, and I get y is 5. Okay? Y is 5. What does that mean? Y is adults. But you could always just set it up like this first and then analyze it last. Now I have to figure out the kids. Now I have 4 equations I can use. I'm just going to go to the top. Let me do it in red. Look at all these lines I have on here. So this will go right there. I go to the top equation. And then I have 8x plus 3 times 5 equals 39. Again, that 5 came from the y that I found. That's where that 5 came from. 8x plus 15 is 39. 8x is 24, minusing 15. X is 3. So I do have my point, but I do have to analyze that with the real life application. So x is 3, x means kids. So it says kids was $3, adult is 5. Biggest thing I can tell you today, use a calc to help you with integers, definitely plus a negative. The next one. Mula has 27 coins. I know we did this before too. Mula has 27 coins that are all dimes and quarters. The value is 435. How many dimes and how many quarters does Mula have? Last time we did it with substitution. Today we're going to do it with linear combination or elimination. So x is dime, and I'm going to say y is quarters. And I bet you I've been doing this a lot longer than you, and I bet you I still define my variables. So don't feel like you don't define your variables. You are not there. I've been doing this a lot longer, and I still define my variables. My first relationship is the total. And that's a lot of times kids don't know what to do because it doesn't have that special word is in there, so a lot of kids don't know. This is very standard. X plus y equals a total amount. So you could write that on the side. That's something you could keep in mind. X plus y is equal to some kind of total amount. So Mula has 27 coins. That means dimes plus quarters is 27. And then the value, so the value is my second equation. Each dime is 10 cents, so 0.1x, right, or 0.10 you could do, plus quarter is 0.25y, equals 435.